This is the TBS Chupito, and this is the second video in the series, and in this one, we're going to assemble it, and we're going to take it for its first flight. In the first video that I've already released, and I'll link to that in the description, we took a closer look at the kit itself. We did an unboxing, we had a look over the airframe, and then looked closely at the new TBS electronics pack that you get for this as well, including the new TBS wing flight controller, and we even tore that down as well. So if you're interested in seeing that, there'll be a link to that video in the description. This one, though, is going to be my assembly. So what we're going to do is get straight on to putting it together. It isn't, though, a complete step-by-step guide, but it should give you a good overview of what you need to do to get this plane together. I've also thrown in some hints and tips, as I found out earlier in the video, that will hopefully get you up in the air too. And then at the end, we'll talk about Inav and the configuration. As I said, I'm not going to sit here and say it's an absolute step-by-step, but I do pretty much cover every single thing you need to do to get it in the air. Before we go into it, I should say TBS did send me this wing to take a look at. However, they've not paid me to make this video. They've not seen this video before it's been published. And as always, my thoughts are entirely my own. I'm not going to go into all of the bits you get with this in this video. If you want to see that, go check out part 1. In part 2 today, we're going to be doing the build of the aircraft. So I've got all of the pieces here on the desk. We are obviously going to need some glue. The glue I used for this build was this Gorilla polyurethane glue. However, I don't recommend you use this. I have used this on builds in the past and it's been okay. However, on this build, it doesn't seem to have stuck to the foam very well and it is peeling off in places. It isn't that anything has come loose, so I'm fine. However, the internet consensus seems to be recommending using E6000, UHU POR, or foam tack. So whilst you're going to see me use this today, I would recommend using one of those other glues as based on the feedback from the interweb. We're going to start with the servos in the wings. Then we're going to move on to some electronics installation, get the receiver ready, and get all of that done before we then go on to mounting the flight controller and motor and all of that stuff as well. The first task is going to be to mount the horns on the servos. We need to center the servos first. Now, they recommend doing this with a servo tool. I'm going to break all of the rules and do this by hand, manually centering them. So that is maximum there. And I'm going to put that horizontal so I can see. I'm going to very carefully turn that there. So that certainly isn't centered. I'm going to come up one more on that. Probably not horizontal. Probably that one there. Very carefully. Yeah, we're not centered there. Try that one. Yeah, that's pretty much that one done. So you can see there. To there. That's as close to center as I think we're going to need on this. So we'll pop the screw in that one. We then need to do the same with the other one, but it's going to be then the opposite way. So what we're going to want to do is figure out where center is. That's probably a bit much. I wouldn't be shocked if that's about it there. So we're going to down to there. Looking good. Perfect. So we've done one way, one the other. I'm going to screw the horn in on that one. And then I'm going to center them. There we go. That one's centered as well. This is Ian from the future, and there is something here you need to be aware of. The control linkages don't actually fit through the holes in the servo horns. The linkages are made of a thicker metal, thicker gauge, and as a result of that, you're going to need to drill out the hole in the servo horn to allow you to put the rod through. I would advise you do it at this point rather than when I ended up doing it towards the end of the build, because it is a lot easier to do it now. I ended up doing this by simply screwing a couple of screws through to open up not the very top hole but the hole below it, and then I was able to get the rod through. I'm simply warning you at this point because it's a lot easier to do it with the servos on the bench than when they are fitted into the wings. Then it's time for us to have a look at the first one in the wings, so we're going to pop off our tape and reveal the cover for the servo, and then figure out which one we want. So it's not that one, it is going to be that one. So this then is going to go in. We're going to pop the cable through. And then that pops through very nicely like that. So that now simply needs gluing in place, and then our cover gets glued over the top. For the purpose of gluing this, I am going to wear gloves because this stuff can go everywhere. I'm also not going to cut the lid open on the glue, and instead I'm going to use a cotton wool bud, which I can dip into the glue and then very carefully use to spread around on the servo to hold it in place. It also means I can then pop a little bit down into the hole there as well, for where the arms go in, and then spread a little bit around in the bottom of the foam too, whilst it might put a little bit down and in. That is fine. Spread up a little bit around the outside as well. And then we can simply take our servo, feed it through, carefully pop him in, getting our cable nice and tight, giving him a nice press to make sure that it does stick down. And then what we want to do is take our cover. We want to spread a bit more over the top of the servo, but then we want to spread around the edge of the cover so we can then glue it on. And hopefully that will hold it in place nicely. Flipping that over, making sure I've got it the right way. Putting a bit of pressure on it. And then that should be perfect. The next task is to do exactly the same with this one again. So it was simply a task of doing exactly the same thing again and then placing them to one side to dry, putting a little bit of pressure on top of the covers to make sure that they glue down in place. So the next task is our motor and motor mount. Now this came pre-assembled. There's nothing I need to do on this, but we do need to mount the motor. Now a quick trick just to show you, to be able to hold this a bit easier, rather than messing around, get the box, jam a big hole in it, and pop it through like that. Now, they do include 4 screws with this. However, these screws do not have Loctite on them. They do recommend you use Loctite to hold these in. So you are going to want something like 243 that I've got here. I'm just going to do what I always do in this situation is I usually pour a bit of Loctite into a bit of unused plastic, just like that. And then the way I usually do things like this is I'm going to place the motor on top, the mount. We're going to take one of our screws. We'll put that back on in a minute. We're going to rotate the screw in the Loctite, so there is Loctite around the thread. And then what we're going to do is line it up for the correct direction. And then pop the first screw in. I'm not going to over tighten the first screw because we need some movement on this to be able to get it in the right place. Fell off. Again, I'm just going to rotate the thread in the Loctite. With these smaller screws, it is a little bit more difficult to do. I try not to usually get the Loctite up towards the head of the screw. With short ones like this, it is a bit more difficult. You can sort of just dip it in the end like that. Or sort of rotate it in like that. And then pop it in. Get our last one. Do be careful with Loctite. It is funny stuff. It will eat plastics. So you do have to be a little bit careful with it. Times. There we go. So we've got... Right, I'm going to put that safely out of the way so that doesn't go everywhere. What I'm then going to do is grab our motor out and just very carefully center it. There we go. Centered on the mount. And then we're just going to tighten it down. 1, 2, 3, 4. There we go. So that's all our screws tightened down now. And then I'm going to pop my nut back on top so we don't lose it. So that is the motor now mounted. Looking at the instructions, they don't recommend, or at least I can't see where they say about gluing in the motor mount. What they say is dry fit the installed motor mount and use the rods to hold it in place. I'm not seeing any comments on gluing it. It's not needed to be glued simply because the way it's designed is the spars go through it and hold it in. So what we're going to do is bend our cable here over and into that gap. So that's level like that. We're going to want this cable to follow this down, although I think we'll have some fun with that bit looking at it. But okay, so we're going to thread that in. Let me just refocus. Push that down. That cable in as well. Get it all to play ball. Not exactly sure where the cables should go in relation to the mount. And the reason I say that is this, is you're going to have 2 spars having to go through this. Right, be careful here that when you push that in, you want your cable to go into the foam like that. So that's gone in nicely there. Sorry, we were out of focus. So there you go. That's gone in there. And then we've got our 2 stabilizers. So we've got this horizontal one. So this one is the horizontal. So I've now got to try and look down and go, well, will that come through or not? Where's the... I'm now trying to feel where the actual motor connector is. Oh, well, that's not gone where I wanted it to. Okay. Trying to see down in there isn't easy. Right there. I think that's a job for some tweezers. Hello? No? Okay. I think we need to pull that back. I'm going to do that vertically. Try and then get the wiring and the plug to come through. Okay, that's definitely a bit fiddly, that. What's happening is it's heading off to the side. Oh, can feel it. Aha! We got it. There. So, I've now got my motor plug there. So if I now look through, that looks clear. Oh, those motor wires are definitely in the way of that verticals. Interestingly, they're definitely in the way of... Let me just zoom down so you can see. There, you can see that where our antenna goes through. Interesting. So we're going to go in with the horizontal spar first. There we go. That one's going through. Okay. I'm going to go in with the horizontal spar first. So let's just wind him through. Here we go. Just looking inside, see what I can see. Yeah, we're fine. We're past that one, out of the way. We then need to figure out the vertical spar. Now that is currently attached to this, which I don't really want it to be attached to that now. I pushed it in earlier and now I can't. Ah, haha. We have it out. Okay, so now we're going to try and ease that through. I can definitely feel wires. I'm definitely poking wires. Yeah, I'm actually seeing wires. Aha! From the bottom, we went through. You definitely need to be a little careful of that when you do it. They're gonna catch. Once we're through, we're through. We're good to go. But you definitely just need to be a bit wary of that as you poke that through there and poke that through there. But now we've done that, we've now got our motor mount fitted, our motor installed. When it comes to doing the electronics on this, it's worth always giving yourself a bit of a dry run and a bench test before mounting it all in the plane. Obviously, we're not going to be able to connect up our motor, but that's fine. What I'm more interested in today is getting our receiver connected, making sure that that's working. We're going to get the GPS connected. We'll get the USB port. We'll then plug it in on USB and have a look at what's going on before we actually get it into the frame. Wiring for this is pretty straightforward. This is all listed in the manual. What I will say is they include a number of harnesses with this that you might be wondering what some of this is for. There appears to be some extras here from my checks that may help you with the installation of the ear units and things like this. For instance, we have a couple of these 6-pin harnesses of different lengths. So there's those two, which are the same length, and they're 6 pins. And then there's a third one of these, which is really long. So you can see that one, those two go to there, and then that one goes beyond there. Again, 6 pin. This will fit the USB port to the flight controller, but it will also fit the digital VTX. And I think the long one is for the digital VTX. That way you can install the cable up front down in there like that, and then that will go all the way back to the flight controller. So what I would do is take your long one, that's for your DJI, your HD0, your Avatar HD, and pop him to one side. Alternatively, we can pop this into the VTX port. They do include a harness. Let me just unplug my soldering iron, which is beeping away next to me. They do include what appears to be basically the official DJI harness, but that is way too short. This one is color coded, this black one isn't. So what I'm simply going to do is use this one, that long one, for the digital. We're going to plug him in like that, and then that is going to be that one there. Next, we need to do our receiver. Now, we have Crossfire, which I'm going to be using on this one. I have pre-wired this already. Do check before fitting that the pinout on the connector they've supplied is correct. Whilst they should be supplying the correct cables, there are multiple cables here and it can get confusing. So even though you might think, oh, that's the right one, double check the pinout is correct for the receiver. Looking at it from here, so if I just pop it in, you should have positive heading towards the back. Think of it, positive towards positive, which is on the battery input. We then have our GPS. Now, I haven't found a direct cable for this. There is a 4-pin cable included with the GPS that will plug into the GPS on this side. So that will plug in, let me make sure I get it the right way around, like that. However, that isn't wired. There is a plug needed for this side. They do include this CAN bus cable, which we don't need, so we're going to pop him to one side. They do give us this DJI look-in cable, and if we look at the pinout on this GPS port, how does this stand? If I just pop that way, it is the right way. No, that is certainly not wired correctly, so we're not going to want to use that one. That leaves one of these two black ones, which is fine. However, this isn't the correct pinout in itself, so we're going to have to do some modifications on that. So when it comes to the GPS, it doesn't appear in my kit to be plug and play. However, that might change in the future. So what I'm going to do is wire that one manually. Okay, so the GPS is done. I have created a harness and I've linked them down there. I've double checked the wiring for that as well. I've left a bit of length on the GPS because I want to attach it to probably the top cover and I want a bit of space on there. The last thing I just want to do is plug in the USB board, which I'm going to assume is going to use this other black cable. And then that one goes down into there as well. There we go. And there we've got our main electronic components attached. So the next thing we can do is fire it up and connect it to Inav. It is worth me highlighting that whilst my flight controller from TBS did come pre-shipped with both Inav 8.01 as well as the correct CLI file installed, yours probably will not, and you will need to flash it with both Inav as well as flashing the correct CLI details. TBS actually lists the CLI download for this controller on the download section of the Chupito website. All you simply need to do is flash your controller with Inav and then upload this CLI, and I will show you how to do that next. You will obviously need to install the Inav configurator on your PC. Here you can see I'm using 8.01, and then you will need to scroll down and find the target listed at the bottom, which is TBS H7 Lucid Wing, and then choose the correct version of the firmware, which as of today is 8.01. The CLI download that TBS have provided is also for 8.01 as well. So if you are doing this in the future where there may be new firmware, it's probably advised to flash it with 8.01 because not all CLIs are compatible across versions. That way you will be in the safest position. However, there technically is no reason you couldn't flash a newer version and use the older CLI dump. Once you have flashed the controller and connected to it for the first time, you will need to select the kind of aircraft that you're going to be using. For this, it's going to be aeroplane without a tail, wing, delta, etc. Once this is done, it'll do the pre-configuration of the flight controller. You can then skip everything else a moment because what we're going to do next is install the CLI dump, which will pre-configure it ready for the wing. As mentioned, the CLI dump is available from the bottom of the Chupito page. You can see here, Inav CLI suggestions. That will then download a file like this, and the simple thing is to simply grab everything, return to Inav, go down to CLI on the bottom left, simply paste in everything you copied, hit enter, and this then will begin to upload the CLI information. It'll reboot the flight controller, and this will then install the pre-configured options that TBS have recommended. All of the configuration has come up. You can see along the top, we're seeing gyro, accelerometer, baro, and GPS. So that is telling me our GPS module is working fine. There are little blue flashing LEDs on the back of the GPS module at the moment. So that is fine. If we go down into the GPS page, I'm not expecting it to find position because I'm in the workshop, but what I'm looking for is data. And you can see down here, we've got total messages, 10 Hertz. What that tells me is the GPS is connected. It's working as expected. We're then just going to check our receiver. Up here, you can see if I move my sticks, we've got Crossfire connected, and that's working fine. I did actually have to change the channel map on mine just to match what I've got on my radio. The channel map wasn't set correctly. We will go over all of this properly later on. More than anything this was just a dry run to check that everything connects, everything looks connected. We go into status. If I move the controller, all of that looks right. Ian from the future here again. Just want to highlight something at this point, that it's a good time now you've got the flight controller on the bench to perform the accelerometer calibrations. You can actually do this once it's fitted into the plane. However, it is much easier to do with the controller on the bench. This is simply a process of moving the controller through multiple different angles as you do the calibration. And my advice would be to do this now before installing it into the airframe. But don't worry if you don't, you can always do it later. At this point, it's worth checking out your mixer and your outputs because this will give us a hint of what we want to connect to what on each side. So for instance, if I go into our mixer, we can see there S1 and S2 are our control surfaces, and then S7, which is the internal one, is our motor. S1 is on the left. So S1 is red. So if you go back up to the status, so S1 from the back is red and S2 is green. So we're going to want our first port on the left looking from the back, our second port on the right looking from the back. So that should just make setup a little bit easier when it comes to plugging in the control surfaces. And then you can see our outputs there. I haven't got the servos plugged in a minute, so I don't need to test that. We'll test that once we get the controller in the plane. With regards to the rest of the configuration, tuning and everything, I'm not touching nothing. This is how it has come from the factory, so we will get it up and running, and then we'll have a look at this all in a bit more detail later, especially with regards to configuring things like the modes, because we need to configure all of this to suit our radio. the next thing we're going to do is install our upper and our lower stabilizers. Before we do this though, I need to install our receiver because this is actually designed to take our receiver antenna internally. You can see there is this cutout around here, and this panel is designed to actually come off. Mine appears to be glued in already from the factory. I don't know, does it need me to give it a big pull to remove it? I'm not going to do it. It seems to be completely attached already. I could probably cut it and it would come free. They do talk about in the instructions that, yeah, mine is definitely glued. They do talk about in the instructions that you can get it off. However, what I'm going to do is simply install my antenna directly. So what we're going to do is mount our antenna into this. So this will actually go into here and go all the way in like that. That then leaves some of it sticking out to go through the hole in this and then out to the bottom. But I also need to get the receiver in as well, because I don't want to bury the receiver here. I want the receiver where I can, well, I'm going to use the words loosely get to it, because there isn't a lot of length on that. As you can see, if I mount that where it goes, the receiver is going to be somewhere here, but at least I can sort of reach in and get to the bind button if I need to. So I've had a look. I can thread this cable through, and that comes through absolutely fine. However, I can't get the receiver past the motor mount. I have tried and it doesn't want to go through. So what I think we ended up needing to do is remove our spars that hold it. I'm going to withdraw the motor mount back a little bit, then drag the receiver in, which I've now done, and then pop our motor mount back in again. There we go. Pop our spar through carefully, hopefully avoiding any cables. There we are. And then our vertical spar can go through as well. Remember earlier when I did this, we did have that cable issue. There we go. That's now gone through like that. And then we can pop our antenna through. Here we are. I'll pop that back. Pop that down. And then that is now in place, ready to be glued on. And you can see my receiver is literally just down by there. This again is potentially going to be a messy job. So what I'm going to do is use another cotton wool bud. I'm going to use this, start getting the glue in where the foams will meet. The nice thing about the cotton wool bud is it does allow me somewhat control where the adhesive needs to go. Come down into that bigger area there, start coming up this side. We're definitely going to get some on the antenna cable on this one. I think that's going to be close to impossible to prevent. And then I'm going to start coming up underneath on this piece. Come around there. Plenty on these joints. We can wipe off any excess of this afterwards. Make sure the surfaces have plenty on, especially on the big flats. There. What I'm going to do then is flip this over to the other side. So I can do exactly the same on here. Working my way around. Again, making sure that there's plenty on the flats. Not missing any. Just going to very carefully on the top there especially. There we go. I think I'm fairly happy with that, how that's gone. So what we're then going to do, carefully pop that in. We can see some glue is starting to come out, which is fine. Before I go any further though, I'm going to now pop in this spar. Here we go. That feels like that's gone all the way in. So that spar now will actually pin that in and hold it in place. I can then very carefully now, just with a bud, just go around, wipe the excess. That is looking good. So then what I'm going to do in a minute, we're going to glue the bottom on and then we'll get some pressure on that to hold those surfaces in place and then we'll be good to go. Before we do that though, we need to do the same with the bottom. So I'm just going to prop that there so that holds in place. Again, take our glue. Going to get plenty of it in on the flat areas. Especially up here, I want plenty on this edge at the top. There, and then we can get our lower, and now we can coat this up with plenty. I want to make sure this is held on quite well because this takes a lot of the impact from landing. So I just want to make sure that we will have a good amount on this. Looking good. Okay. So then again, we've got the two holes. Got our antenna, which we will never get out again. Our spar. Here we go. So here you can now see pushing both of these in. So now I just need to tidy that up, tape that up, and allow that to dry. Whilst I'm waiting for that glue to go off, it's time to talk about the flight controller and powering things like our VTX and our GPS. Now, I'm not going to go over this in great detail in this video on all of the specs and the features. I did that in the first video. If you want to see all of that, check it out. But I do need to confirm some stuff on power. This controller has dual BECs on board. It has a single 5V 1A BEC for powering your GPS and receiver on the side, and then it has a second BEC which supports multiple different outputs, and that supplies your servo ports and can also supply your VTX, your camera, and your digital VTX port. The reason I say can supply is because as standard, the digital VTX port, the VTX port and the CAM port are set to VBAT. They will provide battery voltage output that you get from the input. However, there is a set of pads inside that you can set them to match the same voltage as the servo output. As for what voltage the servo output can be, it supports multiple different options. As standard, it's set at 5V and it supports up to 5A, but you can also change that for high voltage servos as well, 6V, 7.2V, and even 8V as well. However, it's worth noting that if you want to set these to match this, you need to make sure it is supplying enough voltage for your VTX. As I've said from the factory though, it is going to provide battery voltage to the digital VTX, your VTX and camera. If you're using this with digital, that should be absolutely fine, but just take into account if you are using this with analog, because it does have an analog OSD chip on board, just make sure that your analog camera and your VTX does support VBAT voltage, because that's what it's going to get as standard. When it comes to the video system on this wing, I am going to be installing DJI O3. I do intend to install O4 in the long term, but I have a bunch of spare O3 air units now, largely because I've swapped a lot of stuff out for O4. I'll put O4 Pro in it once I order another one, but here and now, I think O3 is going to be perfect for this. Still a really good product and still offers really decent image quality as well, and we still have all the benefits of rock steady and that gyro stabilization too. Now when it comes to mounting the camera and VTX in the cage, this should all be very straightforward. So I'm going to just undo these screws for the antennas first of all, because I'm going to swap them out. There's a single antenna on there at the moment and I want to use dual, so we're going to swap that out for something different. Okay, so I've gone for this longer dual antenna I've got from Flyfish RC. We'll have to see how that performs. Hopefully it will be fine. So I'm just going to get some screws. Is that the right length? Let's have a look. How does that look? Oh, that's perfect. So we'll get the O3 camera mounted first. Trying to make sure that I do it the right way around. And then we've got holes for this already in this frame, so this should be fairly straightforward. They do have a lot of different mounting options available on this. So I believe that is it there. Boom, straight in. You don't want very long screws on this. So next we're going to mount this in the frame. I'm going to go with the top mounting rather than the bottom, because that should help with heat dissipation. Well, at least that's the idea and the plan. But let's see. The only issue with that is there enough clearance on the antennas to allow me to do it that way? So we're going to need to, no, we're not going to need to do that. We're going to need to pop these off carefully, pop that through. Remount. Yep. We're obviously going to want this cover on, but the screws for that actually go through the housing. So let's Let's see how we get away with this. It's a little bit tight. Get that out of the way and we'll pop that in in a moment. There. Then in theory, that'll be able to go up there and there. And then we can get that cover on and screw it in place. Okay, so there we have our VTX connected. We've got our antenna ports coming up just like that there. Definitely a little bit tight, but they're in. Gonna coil the camera cable behind the camera. There we go. And make sure they are all okay. Yeah, that's fine. That should be good. So there we've got our camera pod ready to go in. Next, it's time to start getting the electronics in. Now I'm going to use this long cable they've included for the VTX. There is something though we're going to need to configure on this controller as well with regards to the voltage output, and we'll take a look at that specifically before we fit it. But what we need to do is get the cable in before we can mount our battery unit at the bottom there. So what we're going to do is get this cable in. This should run all the way up down there in the middle. I'm going to bring enough up to go into the controller. And then that should leave plenty then at the front. I'm going to just get myself this. I'm going to use this to push the cable down into the gap. That has fitted in nicely. It does get a bit tighter towards the back. That will go down and in. That leaves us this much up front here for plugging into our air unit. And it has a little bit of spare at the back. I think actually, I'll be honest, I think I've got a bit too much towards the flight controller. Let's bring that back a little bit more. I don't think it quite needs that much. There we are. I'd rather have more at the front of the plane than at the back to be able to get it in. Here we go. Obviously, if there's any other wires you wanted to put in, now would be the time to do that. We've then also got our battery straps that we can fit at the same time. So that's one of our battery straps. There is space for two. I didn't see, actually, did they include two in the kit? I've moved stuff around so much, I can't tell you if they did or didn't, if I'm honest. So I'm going to go and grab a spare one. To hold this in, I'm going to use super glue rather than that other glue I used earlier. This will add a bit more strength for this kind of part. Because this is a battery holding part, I do want a bit more on this than we would on some of the other parts. I'm using the gel for this because the gel is good because it doesn't spread out all over the place too far. There we go. And then what I'm going to carefully do is hold the straps up. So I'm going to grab that one like that. And then this one there. and then try and fit it in. A little bit more on that one so it comes up and round. There it goes. Bit of a fiddly task, this. So they're held like that. Try to get this down and in place. Go. And then push it so it drops into where it needs to go. Quite an awkward job, this, for the first few seconds, but one of the reasons I wanted to use super glue on this is that it will tack up quicker than normal glue. I mean, for me, it's just holding the front down, so we're just going to hold it for a few minutes and let that set. Next is the install of the electronics into the airframe. This is fairly straightforward, but it is a little bit tricky. As I've shown already, the flight controller actually goes in this area at the back. I showed this in my first video, and this slots in. What we need to be able to do, though, is get everything plugged in first. In the kit, they hopefully should include some servo extensions, which we've got. So we're going to plug them in. That is so our servos can be easily connected and disconnected if you remove the wings. So you want to get them in now. Future Ian here, just make sure that you do have servo extension cables for these, because you will not be able to get to these pins once the controller is mounted in the frame. And also make sure you label them when you plug them into the ports, S1 and S2. It will make your life a lot easier later on. Remember, when we looked at the mixer, S1 is the left servo looking from the back, S2 is the right. And if you label it now, you don't have to mess around in Inav like I had to do trying to figure out which one was which. We also want to be connecting up our external board for our USB, so we want that connected. So we're just going to make sure we've got that in the right place and plug that in. We will need to connect our receiver, which is already in the frame, which is that one there. And then we're going to need to connect up our digital VTX connection, which is this one here, which again, I've pre-wired into the frame. And that will go in down there. We also need to plug in the GPS and get that hanging out of the way as well, because we don't want to miss the GPS. So again, we're going to want that one in too. And then hopefully that is all of our electronics connected. I'm just going to use this driver to pop them in. And now we're ready to install the controller in the frame. The last thing we just need to do is somehow, and this isn't going to be very easy, is get this plugged in as well, which is our motor connection. That looks like that goes that way around. So, and then the controller slides down into that bay down there. This is definitely on the more fiddly side of things that need to be done. That's the right way round. So I'm going to get that in. Give that a good push. There we go. So that's now in, everything's there. And the way this installs is this actually plugs in down into the frame. I just need to make sure that that cable is up as well. It goes down and slides in and locks in place. And then there's a couple of screws that you use to get it in and hold it. I'm just watching this digital VTX cable here. You can see we're coming forward, but what I need to do is just move this cable. There we go. So it's in, but it's up out of the way. And then what can happen is the controller should push down and in. And then there's latching tabs for it, where it latches in and then you bolt it down. Just looking through. I think we're there. I think that's it. It looks like that's in place. I can see through the screw hole. There should be a nut there. So then we need to just take a couple of screws. Now, they have included these in the kit. We don't need all of these a minute because some of these are for our control surfaces. I'm going to want a slightly bigger driver for that one. A little bit challenging. Okay, what I will do is, there's two cheats if you have this problem where your screws keep falling off. Number one is a bit of blue tack. Blue tack is a great way of holding screws to your driver, or alternatively, I'm just going to pop it through the hole with tweezers. Didn't work, it vanished. Let me do the second one and I'll get the first one back. Here we go. Here we go, that tightened down. You just try and recover the lost screw. When we figure out where it actually went. There it is. And then that one needs to come into this side. 1, 2, 3, 1, 2, 3. Down and in. Here we go. I'm not going to screw that up too tight because it certainly doesn't need it. And then we now have our GPS. We've got a battery cable, which we're going to want to pop down through that gap down there and then out of the bottom. Ta-da! Got a digital VTX down that side there. So that is nice and tidy. We've got our USB extension, which I'm going to pop up out the way. We've got our receiver wiring here. There's quite a lot of length on that, which is good if we need to get the controller out. But we don't need that, so I'm going to carefully tuck that in down in there. Here we go. We've got our two servo connectors, S1 and S2. I would strongly advise labeling these. And then we've got the GPS there. That's pretty tidy. I just want to, I think I can tidy the receiver up a little bit more. I can just pop down that side. I'm going to put a tie wrap around that. I've got a couple, so we can tie wrap that up, just like that. Here we go. That, to me, is looking pretty good. It's not the tidiest. My builds never are. But I don't think that is too shabby at all. Okay, now the next thing we need to do is set our control surfaces and connect everything up. But I've just spotted something. I've got this on a servo tester, just so I can adjust it to the center point, which is 150. So just... there we go. So that's the center. And then we've got our rods, which go through to there. However, I've just noticed that the rod is too thick to go through the hole in the plastic. I didn't spot this before fitting them, because if I had, I'd have drilled it out at that point. So now I'm going to have to figure out a way of increasing the hole size in there. I'm probably going to do a melty trick than a drilly trick to allow the surfaces to connect. Just to show you in a bit more detail, here is our holes. And there is our rod. The rod is a lot thicker than the hole. So what I ended up doing is using some slightly larger screws to screw through the second hole down from the top, and this then allowed me to put the rod through. Then for the control surfaces on the other side, you simply need to place one of the nuts and bolts through, but before you do that, you need to adjust it so that when the servo is in the center position, I had it at 150 on the servo tester, that the control surface is level with the wing. Unfortunately, when I was doing this, I wasn't quite positioned very well on the camera, so I can't show you it in detail, but the ends on the linkages actually twist and screw in and out, and this allows you to adjust the length of the linkage. And what you simply need to do is make sure that when the servo is centered, the linkage holds control surface level with the wing. So after a bunch of screwing and messing, you can see I've got it centered pretty much perfect here at 150, and then I've got our up and down surface movement. They say there should be 15 mil, I think it is, of surface movement. We'll check that in the manual before we fly it, but yeah, time to go and do the next one. Next, we need to install the carbon spar, and then we can mount the wings onto the wing. Now I'm going to pop this through, just carefully looking where it decides to meet the battery cable. The battery cable wants to go under it. There we go. So that's our long carbon spar for that one. We're then ready to install our wings. Slide in our first one on. Carefully popping through our servo cable. There is a hole for this here to go through, although I seem to have blocked that up with a cable inside. Okay, a bit annoying. Okay, let's move that out of the way. We'll tidy that up in a minute. Something I tidied up had suddenly become in the way. Here we go. Pop that through. Ta-ta! There we go. That's the first one now properly fitted. Let's move all of that over to that side there. That wiring is for my GPS. So we'll do exactly the same on this side. Oop. Pushing that one in, push that one out. Popping the cable through for our servo. They go through nice and easily. There we go. That is our wings on. And then our last task for the wings is to install this rubber band that holds them together. Now this, I can tell you now, is going to be a bit fiddly because it goes down in there. So you can see you've got one hook there and one hook there. I think you're probably going to want a set of pointy nose pliers for this. But let's try it with tweezers. Ah, look at that. Boom. As easy as that. And I was me saying it was going to be challenging. There we go. So that just holds all of that together. And that's now our wings in place. So, from here, the next task is me to tidy up this mess. I need to figure out and label which of the servo outputs is which, because I haven't done that very well. So we need to do that. And the nice thing about that is we can test that in Inav, and if I've got it the wrong way round, we can swap it. That's all really easy to fix. That is the USB connector, and I thought I had that out the way, but unfortunately I didn't. So I'm now just going to pop that back in. I've put a sticky pad on that. And you know what I'm going to do? I'm just going to stick that there. Out of the way a minute. There we go. The sticky pad doesn't seem to be working very well on that. And then I can... I'm probably going to put a piece of Velcro on that or something. So then it's now just a task of connecting up our servo. So we're just going to assume for a moment it's this way round. Plug in. Way around. Plug in. So there we go. They can pop down into the frame. Out of the way. We need to stick our GPS to the top of our cover because that is where my GPS is going to go. I'm going to mount the GPS on the bottom of this here. So that needs to be done. There's a sticky pad that comes with that. So what we're actually going to do is use the sticky pad on the antenna to mount that there. Alternatively, I could 3D print something for that. That would allow me to stick that in place. But very simply, that is just going to go and live there. And then I can plug and unplug that nice and easily when we attach it. And then we're ready for the final configuration. I ended up simply just sticking the GPS a bit further down because I wanted to keep it away from the ESC, and it's just going to sit there above the battery. The last thing I now need to do is install my camera cage. I've plugged in the digital cable connector into the back of the O3 air unit. I'm going to leave the antenna loose and simply stick it in with a bit of adhesive tape in the frame. I'm not going to bother having it externally. If you really want it to fly out and out long range, you are going to probably want it external. But the reality is, for what I'm going to be doing with this, we'll test it internally and see how we get on. This simply then goes down into the front like that. And then we simply need to carefully just get it down. And then it will latch in place. So that will just push in just like that. And then our camera is there ready to go. And then the antenna, I'm simply going to stick it down in there just with a little pad just to hold it. That'll be fine. When I'm flying it in the air, it doesn't always need to be external. Next, we need to do the configuration because now the frame is basically finished. In Inav, you should find pretty much all of the main configuration and the tuning has been done for you. That doesn't mean, though, that you don't need to do some things. I'm going to walk you through step by step what I have done. That doesn't mean, no, there aren't things that you should check, but I will cover everything off piece by piece. Now, we're on the top status screen at the moment. We've currently got it plugged in, but I don't have a battery connected. We will connect a battery in a minute for doing various checks. Before connecting a battery, though, make sure that you do not have a prop connected. If we look along the top under the statuses, everything looks fairly good. We've got gyro, accelerometer, baro, and GPS. So again, it's showing all of our sensors are correctly connected. What I'm going to do is click the reset option here. And I'm just going to check before I do anything that the plane follows the correct movements as I've got set. So I'm going to tip it right, left, nose up, nose down. It's following the movements on the screen, replicating what I'm doing with the aircraft. That just tells me that the configuration for the flight controller is correct. The orientation for the flight controller is correct as well. Next, we're going to move down to calibration. Now, I actually advise you do this before you fit the controller. I'm not going to do this now because I've already done it, but you will need to perform this calibration step. And what you do is follow the process as it shows on the screen. You start with your aircraft level, then you start with it upside down. You show it one way, then the other way. It is a lot easier, though, to do this as just the flight controller on the deck. There are lots of tutorials out here on Inav, but the basics are you do step 1, step 2, step 3, step 4, step 5, step 6. So if I was to hold mine, so step 1 is that. Step 2 is upside down. Step 3 would be that way. So you're seeing the bottom, I'm seeing the top. Step 4 would be up. Step 5, that way. And then step 6 would be nose down. It will walk you through it and it'll do the main cals. That should be the only calibration that you need to do on this frame. Under the mixer, we don't need to change anything, but it's a good place to check some stuff to make sure that it looks correct. You can see down here, everything's been preset for us. S1 is our motor on the left for our servo. So this one from my side, that one from your side. S2 is that one. Remember earlier where I said about labeling the ports before you fit them? I didn't do it, and I'm going to show you how you can check that on yours if you need to do that later. But just make a note of that because it's handy to see that now. Before going to outputs, I'm going to skip down to receiver because we can't perform the next step I want to do in outputs without checking our receiver is doing what we expect. I've got my radio on over here, so I'm going to check my receiver is performing as expected. So throttle down, throttle up. We're then going to check yaw. Although yaw isn't used, we're going to check yaw is working. We're going to check pitch forward and back. Roll left and right. Simplest answer to do is if you go to the top corners with all of your sticks. So top right, you'll see all your channels go full. Bottom right, all your channels go low. And that's a quick way of making sure your radio is working. We also should check our arm switch is working on channel 5. So arm is on channel 5. It's really important it is channel 5, whatever system that you're using. And then the rest of our switches are working. These could be on whatever switch you wish them to be on. And I will look at the configuration on that in a minute, but I'm just going to check mine move through. That's fine. All my switches are doing what I would expect. So I'm happy with that. Now, obviously, if any of your sticks are not performing as expected, you can change the channel order here in Inav. Mine's already set fine. The last thing I'm going to do is check my failsafe is working as expected. To see that in Inav, you've got this little parachute up here, which tells us the failsafe mode. And what I'm going to simply do is unplug my TX module. It's a quick, easy way to check that failsafe is working. You can now see that that's gone red. Depending on the radio system that you're using will depend on the failsafe behavior. I've got Crossfire on this. So as a result of that, Crossfire will actually allow you to set the failsafe options within Crossfire and you can choose what options you want. I have got it set to how you would have it if it was in a standard setup with a flight controller. So it's just going to cut the output and you can see it's done that here. Now we know our receiver's working properly, we can move to outputs. Now this has two very important things. It has the option to enable the motor whilst testing it on the bench. And then at the bottom, it also has our servo outputs. When it comes to the motor, this will allow you to test the motor on the bench as long as you've got a battery connected, but be warned, you must never have a prop connected. This will allow you to check the motor direction. I've already done this actually, and mine is counterclockwise. So just so you know, my motor direction is that way there, or counterclockwise from the rear. So that's the direction you want to mount your prop to make sure you've got thrust. You should check yours, but mine was counterclockwise, so it is worth checking what yours is. To actually do this, first of all, make sure you do not have a prop attached to your motor. Connect your battery to your flight controller to be able to actually power up the ESC. We're then going to go down into here and enable this warning, which says make sure you don't have a prop fitted. And then what we can do is slide up the master slider very slowly, just like this. And you can hear that motor has kicked in. If I go to the overhead to show you this, I'm going to slide it up slowly. You can see the motor is now spinning and I'm just going to check it. And my direction is that way there. That is how I always do it. And that is then making sure that we have the motor direction set right. So our prop wants to go that way. The really important part under here for me, though, is our servos, because this is where we can check, A, our aircraft is responding as expected to movement. So if I pick it up and move it, you can see the servo reaction is adjusting the position, but also check that I've got the correct servo motor outputs mapped to the correct wings. Remember, red is number 1, which should be our left one. So that's this one here, and that one's on the right. Now, the first thing you want to do is make sure your aircraft follows the directions you're moving it on your remote, but also on the aircraft as well when you're naturally moving it. To demonstrate this, I'm going to plug in a battery. I've got the prop removed, so there is no prop on this. So now the battery is connected. If I hold the aircraft in the air, what we're now looking for is that the reaction matches what I'm doing. So, example, tip the aircraft forward. You should see our control surfaces come up, which they have. Tip the aircraft back. You should see your control surfaces go down below the wings. Tip this way. You should see the control surface come up to counteract. So this surface should go up and this surface should go down. And then the opposite way, the same thing should happen. The wing that's up, the control surface comes up. The wing that's down, the control surface goes down. And that is to counteract my movement. And then when we're holding it flat and level, they should be flat and level. So again, if you don't fully understand how this works, if we tip it this way, our flight controller is then trying to say, no, I want to be level, and is pitching this wing up to push it back down. With regards to then our radio, we want to check that our surfaces correctly match our radio. So I'm going to put forward, which is nose down. So it's going to pitch the two surfaces down. I want to pitch up, pull back, and the surfaces come up. So again, see that, see that. Then we're going to check left. So what we're saying to the aircraft is, I want to go this way. So what it's going to do is pitch this surface down, this surface up, which is correct. And then that way, it's going to do exactly the same, pitch this surface up, and that surface down. So that now matches my movement correctly. Next, I want to check which servo output is connected to which port, just to make sure I've got it right. And the simplest way to check that is as follows. I'm going to hold it flat and I'm going to pitch forward. Both should go down. It doesn't matter if you pitch back and both go up. What you're looking for is both do the same. So we know I'm pitching forward. That one is going down. If I return to Inav, I am going to reverse servo 1. We know servo 1 should be the left wing, which is this one here. I've saved that option, and now I'm going to pitch forward again. And now you can see the left one is now going up instead of down. So I've reversed this one. That is S1. So that tells me that wiring is correct. I've got S1 on the left, S2 on the right. Obviously, you're going to make sure you set this back. You cannot leave this like this, but it's just a good way of checking if you've got them the right way round. So now I've come back in. I'm going to make sure I've turned that off, clicked save again to make sure that it's now gone back to stock. And then what I'm just going to do is check on my radio that it is now doing the correct things again. So I'm going to pitch forward, both down, both up. That's fine, but we now know the configuration is correct. One last check you need to do before flying your aircraft is to make sure that you have the correct amount of deflection on your control surfaces, on your elevons. Now, TBS list the values for this at the end of the manual for the Chupito. They state values for both pitch and roll. So for instance, pitch, they recommend plus minus 12 millimeter. So that is when you pitch your remote control stick, you should have 12 millimeter of movement up or 12 millimeter of movement down. And then when you're rolling the aircraft, so you're actually performing a roll maneuver, that should be 15mm of movement rather than 12. Your adjustments for this are available both in the servo mixer as well as the outputs. Here you can see our output levels, our maximums and our minimums are set as standard. Our mids, you can see, have been adjusted, and then our mixer has our percentage values listed in here for the movement as well. Next, we're going to move down into ports. Now, there really is nothing for me to do under here. It came pre-configured for that digital VTX that is already enabled on the correct UART. I have plugged in my DJI O3 unit and it's working spot on, so we don't need to touch anything under here. Next, moving down to configuration. Now, I'm not going to change anything under here, but I do want to highlight two things. First of all, they have permanently enabled auto launch, which is brilliant. However, continuously trimmed servos for fixed wing is not enabled. If you want to enable that, you can. However, it isn't enabled as standard. Next, we have tuning and advanced tuning. We're not going to touch anything under tuning, but I am going to tweak the advanced tuning auto launch settings. Nothing else. I just want to tweak it so it does give me a pre-idle of the prop rather than it sit there with nothing. Programming, we're going to completely ignore. Receiver, we have already done. Obviously, if you were configuring this for any other type of receiver type, you could do that under here. I'm using Crossfire. Mine is working absolutely fine, so we can leave that alone. Next, we're going to move into modes. Now, arming needs to be channel 5. Regardless of the system you're using, it should always be on channel 5 high, so make sure that your arming is set to that level. So for there, you can see my switch is working fine. Modes wise, I've set mine up as follows. You've got angle mode, which is on my lowest position there. We then got acro. Remember in Inav now, acro isn't a selectable mode. Acro is the mode it goes into when you don't have a mode selected. So if I move my switch into acro, you'll see at the bottom here, acro has shown up. If I just move it back into angle, you can see it's off, and you can see the switch position goes to nothing, and that is what enables acro mode. So if you do get a bit confused on Inav, acro isn't an option you select. Acro is where it ends up if you don't have any options at all. You then got manual mode, which I've got available up there as well. And then I've got the navigation modes, which I've enabled. So they are positions in the mid positions. So I've got cruise mode and I've got loiter mode. I also have return to home set on 2 switches. I have return to home set on that separate switch over there. But I also have return to home on this corner button over here as well, as an emergency that if I've got a problem, I can just press and hold it rather than worrying about having the switch. And it's a piece of advice I always give people for having return to home on a button, because at least if you're in a bit of a sticky situation and you're panicking, you're not exactly sure where your switches are, you can't see your switches when you're in goggles, you can just press and hold that, and that will go into a return to launch. You could even do that for a loiter or something like that, but it is a really nice and quick way of triggering a failsafe, and then you can lift your goggles up and spend a bit of time then understanding where you're at. Moving down, we finally have the rest of the settings. We've got the servo, auto, trim, and auto level configuration, which I've got on a switch. So which is those two there. And then finally, right at the bottom, there is a user 1 switch. Now, I have currently got this set at maximum. This, I believe, and I still need to play with this a bit more, enables the power output for the VTX. This will help prevent your DJI O3 or O4 air unit from overheating. I am going to set this on a separate switch. I haven't done it yet. I don't advise you set it on an arming switch, because if you cut the power before recording is stopped, it could corrupt the SD card. But what I am going to do is set this on a separate switch on the radio to enable me to power down the VTX and prevent it overheating. For instance, while we're waiting for GPS lock, this is quite an important feature that you do want to add. And then you might want to add your buzzer option as well. Buzzer is quite handy to have when you have a problem or when you're trying to find your aircraft when it's landed. I haven't currently got it set. I've actually run out of switches on my radio, so I need to mess around and figure out which one I'm going to set it to. But at the moment, it's currently not set at anything, but the beeper is available there if you want it. Now, the final thing I'm just going to talk about is your OSD layout, because it is worth checking. It might not be set up as you want it. I have pre-configured mine, and that is how I've got it. But obviously, you can set this to any way you want. So there you can see we're all done. We're ready to go. There are just a couple of little things we need to talk about. Battery choice, center of gravity, and I just want to show you a couple of things inside as well. Now, with regards to battery choice, there are a lot of options here. TBS recommend 4 to 6S. They're saying 800 milliamp hour to 1800 milliamp hour. I'm going to be testing with a couple of these pizza packs, which are 1200 milliamp 6Ss. That's what I'm going to use in here. With regards to balancing the aircraft, the center of gravity, there are marks on the frame for this, the airframe. These marks are right down here. You can see there, and there is where the marks are. I've got the battery installed at the moment, so if I just get my fingers under it, it's not the easiest. I'm pretty good. I'm a tiny bit nose heavy, it depends where I get them. There you go. I'm pretty much on the marks there. We're close. We're very, very close. You can see inside, I've got one of those batteries in already. I did add some of the TBS battery grip to the bottom plate. I noticed while the battery goes in, depending on where I needed to move it, it did move around a little bit. If I just pop that out, I did add in some of that super sticky grip stuff onto the wood. I did it in strips basically, and that really helps to keep the battery in place. It seems to fit okay with that 6S there, and that gives me my balance. Just popping back in. It's a little bit tight, but there we go. And then I sort of got that about there, and then I just strap that down like that. Obviously, my antenna for the O3, I've literally just tossed it in like that. I've just left it there. I think that'll be fine, especially when we're flying in the air. Remember, we're flying you're not flying on the ground. You're not flying horizontal so much to yourself. You're going to be in the air, depending on your altitude, obviously. You could make a bracket to mount it externally if you want to. I'll talk about how I find the performance on that later on, but overall, yeah, pretty straightforward. Then we've got my GPS module, which I've got directly above the battery. I've got to tidy up this. I'm not happy with my USB port at the moment. I'm literally just jamming it in like that. And then we just pop the top cover on, give him his press, and then we're ready to go. I'm not going to show you flight footage in this video because of the length this ended up being. I'm actually going to put that in a separate third video, which has already been published. There'll be a link to that at the end of this video, or that is in the description as well. What I do want to do, though, is share with you some thoughts around what I think about the build of this plane and overall my opinions up to this point. I have to say, this has been one of the most straightforward builds I've ever done from a wing perspective. And that isn't really because TBS have done anything magical, but it is little things that they've done that do make it very straightforward. The kit itself is very simple to put together. As you have seen, glue in the servos, glue on the stabilizers, mount the motor, mount the electronics, maybe a little bit of wiring, and it's ready to go. What really helps with this, though, is the pre-configuration and the plug-and-play installation of the flight controller. So, for instance, the flight controller just slots in and there are 2 screws. There's no messing around trying to come up with mountings and gluing and sticky pads. It's done for you. Most of the wiring is done for you. Not all of it, but most of it is pretty straightforward. You're not messing around doing everything from scratch. I literally took a very hands-off approach to the configuration on this. All I really did was check my receiver was working, the mode selection, and made sure GPS was working. A couple of other things were correct. I didn't touch rates. I didn't touch any of the other configuration. I didn't even mess with the actual auto launch settings. I left it as it was for the initial test. And I have to say, as you will see in the third video, it went very, very well. I will obviously share my main thoughts and opinions on the Chupito in my main third video. I'm not expecting this to be a very popular video simply because of the sheer length of it. The third one will be first flight and opinions, and I will share some of what I've discussed here again, but I also felt it warranted talking about that stuff in this video. Really, as I shown in the video, just a couple of little things to check up front. Drill out your servo horns before you fit them in the wings. It's a lot easier. Sticky pads for the batteries recommended. Make sure you use the right glue. Other than that, it is really straightforward. So, that is the Chupito. If you're interested in finding out more, there will be a link to the original video in the description, the third video in the description, and a link to the TBS website. I want to say a big thank you to Trappy and the team for sending this one over. Really enjoyed it so far. Please do check out video 3. And finally, I just want to say, if you'd like to support the channel to allow us to keep making content, please do consider checking out the links to my Patreon as well as buying me a coffee. It is only through the support of my Patrons are able to keep making content on this channel. And if you'd like to support us, please do consider checking it out. Anyway, that's it. Go check out number 3. Stay safe. I will speak to you soon.